Hello, 6th and 7th graders. I already posted a video about making a scatter plot on Desmos. I now want to show you how to do it by hand. So in the event that you're not interested in going to Desmos, I have a way to do a scatter plot by hand here. Unfortunately, you're going to see my back a lot as we're doing this because I have to do a lot of writing today. So what I have started here is I have decided that I'm going to compare push-ups to sit-ups. Let's say that I sent out a survey and I was asking everybody, how many push-ups can you do and how many sit-ups can you do? And we're going to see what they say. Now, obviously, I did not really send this survey out, so I'm making up the data as I go. But I just want to show you how we can start building it. So the first thing is our graph is going to be just a quadrant one. So you're just going to make like a big L. We don't need to worry about negative numbers, so we don't need to worry about the rest of quadrants. We only need quadrant one. So I have a big L. And then I need to label my X and Y axes. In this scenario, I don't really know which one depends on the other. Maybe more push-ups means more sit-ups, I don't know. So in this unique situation, because I don't know which one depends on the other, it doesn't matter which one I put on other axes. Now, in some of the questions you may ask, you may think, well, one certainly will depend on the other. Like how many pets you have and how much money you spend on dog food. That's going to depend, like the amount you spend is going to depend on how many you have. That means that how many you have is going to be the one you put on the horizontal, and how much money you spend is going to be the one you put on the vertical. So for your situation, they may depend on each other, which means that would be where you would put it. So if you are ever in your question thinking, this one depends on this one, whichever one depends on the other one, that one's the one that goes on the vertical, and the one that depends on it goes on the vertical. The one that you think like that one's the one that the other depends on, it's the independent, that goes on the horizontal. Sorry, it's a little confusing, but I hope that makes sense. If not, email me. So push-ups and sit-ups, I don't think one depends on the other. So I'm just gonna put push-ups down here on the bottom. And I'm gonna put sit-ups on the side. Okay? 0, 0 is important here. Okay, and now at this point, this gets a little interesting. So there might be some of us that can do like, I don't know, 100 push-ups without stopping. Maybe. I'm gonna think, and it depends on the data that I collect. If the data I collect, the biggest number, the maximum that I get is 50, then I know the biggest number I need to put up here is 50. So I'm gonna go with 50 as our biggest number. Okay, and now maybe sit-ups are going to be the same thing. So I'm going to say maybe 50 is the max number of sit-ups someone can do without. Sorry, there was a squirrel outside and Cam had to tell me about it, so I apologize for his growling. Okay, so maybe 50 can be the number of sit-ups that someone can do too. Now, I don't think I'm going to be able to do 1 through 50 down here. It's going to be a lot of writing. So what I'm going to do is I'm going to go up by a certain amount each time. I think maybe I'm going to go up by 5s. Okay, so we're going to go 5, 10, 15, 20, 25, 30, 35, 40, 45. Oh, well, that's okay. So I'll just scoot this in. And if you're doing this on graph paper, which you should be doing this on graph paper, you would probably have a better chance of spacing this out. I'm just going to pause it and do the rest of this video. It's not ridiculously. Okay, so I have the graph done, and now this is where I get to start plotting my data points. So maybe we had one person who said they could do 20 push-ups and 50 sit-ups. So I go over to 20 for push-ups, and I go up to 50, and I'll plot a point there. Then maybe I'll have someone who said, oh, well, I can do 40 push-ups, but maybe only 25 sit-ups. So we'll do that here. Maybe someone's like 50-50. Like this person is like, I'm jacked. I can do whatever. Then we're probably going to have some other people who are like, no, I can't do any. Maybe they can do 5 sit-ups, but 0 push-ups. Maybe they can do 5 push-ups and 10 sit-ups. You know, couch potatoes. You know, they're like, man, I don't need to be able to do sit-ups or push-ups anyways, which I understand. I can't do many push-ups. Maybe we've got someone who can do 20 push-ups and 35 sit-ups. Maybe we got someone who can do 40 push-ups and 45 sit-ups. In my general thinking, and again, I'm not collecting data, but this is just my kind of assumption about the data, is if you can do a lot of push-ups, you could probably do a lot of sit-ups. That's just my guess. So 45 push-ups, maybe 35 sit-ups. I think sit-ups are a little bit easier than push-ups, so maybe 30 push-ups and another 50 sit-ups here, maybe 20 push-ups, but like 45 sit-ups. Let's see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay, there's my 10 data points. There's my scatter plot. I did it. I'm done. Hooray. So now that my scatter plot is done, let's start talking about some of the key words that are going to be important. One of them is trend. Trend is what is happening with the data. Like, is there something that seems to be happening? Like, if I talk about the general trend, I can then use the trend to like predict future data points. So in this trend that I've built, I can kind of see that most of my data lives up in this area. There isn't really anything going on up here, but as we get smaller, both numbers get smaller, which means if we get bigger, both numbers get bigger. So both of those are ways that you can talk about trend, okay? As you get more push-ups, you get more sit-ups. That brings us into correlation. There are 3 types of correlation. I'm going to write the word correlation. Correlation. There are 3 types. There is a positive correlation, there's a negative correlation, and then there's no correlation. Positive correlation is when one variable goes up, the second variable goes up, which means as one gets bigger, the other one gets bigger. This is an example of a positive correlation. As my push-ups go up, my sit-ups go up. So this is a positive correlation, okay? Positive relationship. Correlation is also like a relationship. Negative correlation means that as one goes up, the other goes down, okay? So like the more video games I play at night, the less sleep I get. That's a negative correlation. More video games I play, that goes up, right? So 4 hours, 5 hours, 6 hours, 10 hours. The less sleep I get, right? Now I'm only getting 8 hours of sleep, 6 hours of sleep, 3 hours of sleep, right? That's a negative correlation because they're going in different directions. As one goes up, the other goes down, okay? No correlation is kind of what looks like it's going on up here. If I ignore these 2 dots up there, that's no correlation. That means it's not going up or down. That means that there's no real relationship, that one doesn't really depend on the other, which kind of could be true for this. The amount of sit-ups you do might not depend on the amount of push-ups you can do, right? Because they're 2 different muscle groups, right? One's your abs and the other ones are your arms. So they might not depend on each other. And if I ignore these 2 points down here, that's kind of what this looks like, right? There's no real obvious correlation up or down here, okay? So like with correlations, when you have these dots, you can kind of draw a line to represent it. So I'm going to pick a different color here real quick. But if I was to draw a line that would represent this data, it's like a line of best fit or a trend line, I would make it probably go through these 2 points and then kind of just up through the data like this. Okay, that kind of represents the data. Not well, it doesn't hit a lot of the points, but it kind of shows the trend of the data, that as one goes up, the other goes up. But if those 2 points weren't down here, if these 2 points weren't down here, then I wouldn't be able to draw a line through this, because who's to say? I mean, maybe a negative one, because you got some that go down here, but then you got this guy that goes up here that still could be positive. So there's no true line that we can draw, which means that there's no correlation. But these 2 points make it look like there is a correlation, which brings me to our next word, which is outliers. Outliers. So some graphs might not have an outlier, some might only have 1. This one's got 2. And there's 2 outliers of these 2 down here. The reason these 2 are outliers is because they are way different than the rest of my data. They're way down here, right? They don't look like the other data points, okay? So these 2 points down here also change the trend. If a data point changes the trend, then you know it's an outlier. They don't go. right? These are small numbers, 5, 10, where everything else is 30, 40, 50. So these are the ones that just don't fit. There are outliers, okay? So we've got correlations, we've got trends. A pattern would be similar to a trend. A relationship is like a correlation. What relationship did the data have? And then we can talk about our outliers that don't really fit with it. From this, then we can start making assumptions about the data. What does it mean? Well, my assumption, and again, all of this is based off my assumption because I didn't really collect data. My assumption is that if you can do a lot of push-ups, you can probably do a lot of sit-ups, which means that there's a positive relationship with the amount of sit-ups you can do and the amount of push-ups you can do. That would be my assumption, because I'm thinking like if you are athletic enough and you care enough to be able to do a lot of one, you'd probably care enough to do a lot of the other. And if you're like, nah, I don't really care too much, then maybe you're not really good at doing either. Okay. So, but if I ignore those 2 points down there, I wouldn't be able to say that there's a relationship at all. Based on this, I'd be like, there is no relationship. They're different muscle groups. So maybe you've got really strong biceps and chest muscles, but you got no core strength. Or maybe you can do a ton of sit-ups and you've got great core strength, but you've got like no upper body strength and you don't care for push-ups. So it all depends on what the scatter plot kind of looks like. And for me, because of these 2 data points, I can say there's a positive trend here, and I'd be able to say the amount of sit-ups and push-ups do rely on each other. If you can do one of the one, you can do a lot of the other. Okay? So your data may show something a little bit different, but just kind of have an idea of like, what do you think that relationship's going to be? You know, if you have a lot of pets, do you think you buy a lot of pet food? Probably, right? If you're really tall, do you think you have bigger feet? Maybe, right? If you're older, would you be taller? Maybe, okay? So those are all the relationships you have to start thinking about and then saying, does that relate to what my scatter plot looks like? Okay? So I hope that answered a lot of questions and that you've got a better idea of how to do part 2. As always, if you have any questions, please email me. I'd be happy to talk about it with you. And yeah, I hope to talk to you guys soon. Bye.